So this actually is the easier of the two cases. The other case would be a slightly more difficult. Is that okay? Up to you. Can you follow all the steps? I mean, I'm pretty sure in exam we will not ask you to redivide this because it's just too complicated. And it's algebra, but it's just too many steps. But the one case that might ask you is, see, for the special case that when K is perpendicular to the boundary, meaning the I is 0. You can repeat all this derivation using this case. Instead of substitute I equals 0 after you do divide that, because when you start from this equation with I equals 0 in the beginning, then all these equations will be simple. Okay, so that you might be asked. Makes sense. I mean, for the PhD comprehensive exam, that it's a possibility to ask because that theory is simple enough, right? But the full component, the two components are slightly different. But I mean, let's just work out the steps so you know the procedure, how to solve this. Okay, is that okay? So, no questions? Oh, all right, so we'll now struggle this second case, so we need to erase something, right? We already erased the vector thing already, so we need to figure that out. So now erase all this. This is all for the first case. Let's erase all this. Now we change that. We don't have E in the Y direction, actually B in the Y. So instead, so likewise, this is you look at the panel B in figure 7.6. Now it's B in the Y. But the boundary equation are in the x vector, so we need to figure that out how to do that. So likewise, be the same as B pi and B double pi. So they're all in the Y direction, right? And there's an ambiguity between the two cases, especially for I equals to 0. We'll probably point that out later. Let's just work that out. What to do, because these are in E, but Y is in the B is in the Y direction. Now we could figure out how to solve for E in terms of B, right? And we can actually use that equation. I mean, there's some K cos B, K cos E0, right? There's some K cos E0, right? But we have this equation in E0 also. We need to figure that out. To do that, I mean, we can either use another cos particle of that one, or use the Ampere's law. I mean, this is the Friday's law. We can use the Ampere's law to figure that out, to basically solve E in terms of B, because we probably will need that anyway. Let's forget all this. Yeah, use the Ampere's law. You pick this partial D, partial D. There's a J, but there's no J for our case. There's no free current. So IK, so basically K cos H. H is B over mu equals 0. you have power minus I omega. I cancel, so you have minus omega d. D is epsilon e. So E is we solve that. E is minus k cos b and divided by mu epsilon omega. And omega are the same for all the ways. So it's just proportional, right? So basically k cos b. And so basically k and b is in the y direction. So k cos e is also in the y direction. K cos e. So again, the 2 will not give you, because the z n is in the z direction. So k cos is in the y direction. And so that won't give you any extra information. So 2 is not useful. And now you can use equation 4. So k cos e in the y direction. So every term is in the y direction. N is in the z direction. Y cos z is in x direction. So every term is in x direction. So only need the component. So everyone is the same. Okay. So number 4 will give you right. Okay. You need the y components of this. Your k cos e is the y component. So E has the, let's figure it out. So E has, say E0, this is B0, E0, E0 is minus K, you have the same term B0, K cos Y, and divided by mu epsilon omega. And then there are phase vector, forget about the phase vector now. And now K cos Y is you have Kx, you have Kx and Kz, the case is on the xz plane. X cos Y is Z, so Kx cos Z component, and then Z cos Y is minus X, minus Kz. Okay, so again, this is K cos Y is in the Y direction, which is 50 vector B0. And then cos in the, we just need to figure out what the B0, this is basically B0. BC over omega is everything proportional to BC. And then you might as well need to figure out what BC is related to E0. I mean, then you can actually take the K out. So that would be minus B0. And we take the K out. Kx is sine I. X component is sine I. Z. And then Kz is cosine I. Okay, and this is a unit vector because the magnitude of this bracket is sine squared I plus cosine squared I, which is 1. So this is a unit vector, and so this is what we call, this magnitude is what we call the EC. Okay, yeah. So basically, B0 is E0, you multiply epsilon mu epsilon omega over K times E0. Right? There's a negative sign. Right? So this is our I mean, it depends on the right, whether you define the right hand rule or the left hand rule. You look at the Jackson, how Jackson divided that. The incident wave, Jackson point the electric field in this direction. So it has positive KC direction sine I and negative component in the x direction. So this is the right direction. So this is what is E0. E0 times this vector is this vector defined in this direction. So it's this. Given by this, and then you can use omega over k is this one, and omega over k is 1 over this. So this is basically minus. All right, so that so far, so I mean, we are using this one for this one because you have k cos E0 is omega B0, and B0 is this one. You have a minus. Well, yeah, I'm actually not using this one. So you have a k cos E0 is B0, which is that one, right? Is B0, which is this one, and then you divide it by mu, so minus, and you get back to the same. And both are the same medium. This one will give you a BCO double pi, and BCO double pi will relate to ECO double pi. And well, we need to be a little careful. So this is for ECO, ECO double pi. So everything should be the same, except that there's a minus sign in the C component. After you pull that out, it's minus ECO double pi, and mu. So everything is the same. Kx is the same, but Kx is the same. Kc has changed the sign for double pi for the refracted ray. So this one changed the cosine. Which in Jackson case, it actually defined it as easier as in this one, easier double pi, and that actually make a negative sign here because this is I mean this is in this vector, so you have positive x component, positive z component. So this is your ECO double pi. So ECO double pi again, the BCO double pi is minus of ECO double pi multiplied by all this divided by k. Right. And so it's basically this is the same as this one. So you the BCO is ECO plus ECO double pi. Right? Because this is this is just omega times B0, omega cancel. But these both of them are of the same form. B0 is this one. So B0 double pi is this one multiplied by E0 double pi. They have the same form. Add up. Okay. And then, but this one is similar because similar to the original incident wave, and the electric field definition projection is also the same. ECO pi. So the right, this one equals to that, and they both have a negative sign. It's E1 pi over U pi and EC pi. Okay, so that is on equation 4, and we can now cancel the negative sign. So that took a while. Let's see if I got this from this is the second equation in Jackson 7.40, right? It's over omega ECO plus ECO double pi. The other side is ECO pi. Okay, we got this one, right? Right. So got some figuring out to get to this one. So the second case is one. So we already used 2 and 4. See what should we do? One of them will give you redundant equations. So see if we are fortunate. If we use 3, the formula C is number 3 is simple, but then it's a cause product. Whether we want to use, we might use 1. One is a dot product, might be easier. N is a Z. Basically, just take out the Z component. So multiply by sign I. Right. Then right, E. This is the form of E. Right. So only complication you have is epsilon. Why don't you try that? You have epsilon, and so the whole thing is just E0 sign, and then dot in the Z, pick up a sign I, and then the other case is the same because kx is the same, so both have the same sign. So add the E0, that's E0 double sign I, but I have a feeling that this will give you the same equation. This, the right hand side is E0 pi, right? And then E0 pi sign out. Right. But then we have the Snell's law, right? We have the Snell's law. Snell's law is n. Snell's law is n. We divide it by n, right? N sine I equals to n pi sine I, right? And now we have sine I and sine R. And n is the ratio between phase C and the phase velocity. So sine, you can express everything like a sine is sine I n over n pi sine I, which is proportional to epsilon. So basically, square root of this epsilon, the speed is proportional to inverse of square root of epsilon, right? So n, so like n is epsilon mu divided by 0. So everything proportional. And so it's proportional to epsilon 0 divided by epsilon 0. Oh, so let's see if yeah, I think that so epsilon psi I. Well, we already have the ratio psi I. This is psi. Let's just work that out. Epsilon is 0. And then this is square root of so basically I'm saying that sine I cancel. And then you have epsilon, and the square epsilon, you can divide it. This thing to this side becomes a square of epsilon divided by mu. And the rest is this divided by that. This is putting epsilon pi in the numerator, epsilon pi divided by mu pi. So this two, we covered this one. This is just the same. So number one didn't give you independent solution. So unfortunately, choose one. Okay, so we're only thing left is number 3. All right, that's okay. So figure out number 1 doesn't give you answer. Right. So number 3 is E0 cos n cos z. So E0 again, E0 is this one cos z. Z cos z is 0. X cos z is minus y. So this is E0. So E0 minus y, but you have a negative sign, so it's y. Everything is in the y direction, but this one you change the sign. E0 double pi. X cos z, x cos n, x cos z is y. X cos z and minus y, so you have a negative sign. X cos. So number 3, you have E0. That's cosine I. E0 pi also cosine negative sign. Okay, and then the right-hand side is the same, except that change to E0 cosine R. Okay, so that should be the other equation of 740. The first equation in 740 is cosine I E0 minus E0 double pi minus cosine R E0 pi. Yeah. So you got these two equations in 740 by this vector equation. So far so good. So we have 2 equations. And then following the same method, yeah, out of time, but this one, why don't I leave you as exercise to get the Jackson's 7.41. Right. This is 7.41. E parallel to the plane of incidence, so meaning E is on the plane. So you should recover 7.41 by this equation, just like what we did for the first case. Okay, why don't I leave it for you? The same is you use the same trick or use the effective index and the Snell's law to simplify to Jackson's form. But this should be straightforward, just like what we did for the first. Is that okay? The complication is figure out what these two equations from these 4 vector equations. Okay.